So today we're going to be discussing about the two major chemical bonding, the ionic and covalent bonds. But first we must need to change into setup. Setup change in 5, 4, 3, 2. So we're going to be discussing about the two major chemical bonding, the ionic and covalent. Covalent. So in ionic, this is a type of bond wherein the nonmetals and metals combine.
Jan! Ha!
Whoa, it worked!
So the electrons are being transferred, not being shared. So the arrow in bonding the chemical is an arrow. While in covalent, this pertains to the bonding between nonmetals plus non-metal. And the electrons are being shared. So we're going to use the dash type of symbol. So in naming ionic compounds, there are conventions to follow. The first one is you're going to look for the element that has a positive charge or a cation, then followed by an anion. Then you're going to take the second element, the root word of the second element, so the first element plus the second element but the second element must have the root word plus I-E-E. For instance, let's give an example. Let's say we have, this is read as sodium chloride. So the two elements that are present in this compound are sodium and chlorine. Cut. So in naming ionic compounds with polyatomic ions present, we're going to take the name of the first element plus the name of the polyatomic ion. With the use of the magical periodical table. In naming covalent compounds, you're going to add prefixes to the elements.
Trust me.
And add IDE to the second element.
There are three other types of chemical bonds: hydrates, binary acids, and oxyacids. Hydrates are compounds where water molecules are involved. So for example, if we take copper 2 sulfate and add 5 molecules of water, we get copper 2 sulfate pentahydrate. Not common misconception, it's not penta water, but it is pentahydrate. The next chemical bond is the binary acids, or compounds, gaseous compounds that are dissolved in water. So, for example, if we take hydrogen fluoride and dissolve it in water, it will change from a gaseous state into a aqueous state or a liquid state, and it will change its name from hydrogen fluoride to hydrofluoric acid, getting the root word of the second element and suffixing a IC plus adding the word acid at the end. Lastly, we have oxyacids, or acids containing oxygen with water. So a common example of this would be nitric acid with its chemical formula of HNO3, as well as sulfuric acid, which is H2SO4. A common thing to look for when looking for oxyacids is get at least an atom of hydrogen as well as an atom of oxygen in a single formula.
So that's all for today. Hope you learned something in this mini tutorial, which I really tried my very hardest in recording and in teaching. So rolling in the sea. What?